Question 7. Chlorine is used to decrease the number of microorganisms in water. When chlorine is added to water, there is a redox reaction shown by the equation below. We have to deduce the oxidation state of chlorine in HClO and the oxidation state of chlorine in HCl. So if I start with HClO, then I know there are a few oxidation states that I have to remember. For example, O must be -2 and H must be +1. So in HClO, that leaves us with Cl must be +1 because overall in that compound it must be 0. In HCl then, again remembering that H must be +1, so this Cl must be -1. We're then asked to give two half equations to show the oxidation and reduction processes that occur in this redox reaction. Reminding myself then that oxidation means the loss of electrons, reduction means the gain of electrons. So in our equation we start off with Cl2 in its elemental stage, so it must have an oxidation state of 0. In HClO, it is becoming +1, and in HCl, it is becoming -1. So if it's going from 0 to +1, that means electrons have been lost. So the product HClO is going to be the product in the oxidation half equation. From Cl2 to HCl, electrons have been gained, meaning that's going to be the product in the reduction half equation. Both of these are going to start with Cl2. Now we just said that to go from Cl2 to HClO, electrons must have been lost. So the electrons are going to go on the right hand side of my equation. In order to balance out these H's and O's, I'm going to need to add in some water, which again I can see in my equation above. So I'm going to add some waters. Now, I'm also going to need some H pluses. The reason for that is I need something to balance out these negatives on this right hand side, and also to make it so that I have the same number of H's on either side. So that's where my H pluses are going to go. Now, be careful, don't just leave it there. This doesn't yet balance. I've got 2 Cl's on the left and only 1 on the right hand side, meaning that I'm going to need to produce 2 lots of HClO, and I'm going to need 2 lots of water and produce 2 electrons and 2 H pluses. Could do something similar for the next one then. So Cl2 to HCl we know is a gain of electrons, so my electrons are going to go on the left hand side this time. And I'm also going to need some H pluses here. Okay, because I've made HCl, I'm going to need to add some H pluses. Again, looking at my reaction, I'm going to need to balance this equation because I've got a Cl2. I'm going to make 2 HCl's, and I'm going to need 2 electrons and 2 H pluses there. Okay. The next question then, we're told that chlorine is reacted with cold aqueous sodium hydroxide to make bleach. Now, my immediate reaction is, what is the formula for bleach? Well, it's going to be NaClO. So when it comes to writing my equation here, I've got chlorine and sodium hydroxide, which are going to make my bleach. It also has the product NaCl and water. Just move up a little. Making sure that my equation then balances, so I'm going to need 2 lots of sodium hydroxide to make that work. The next question then. So, the concentration of ClO- ions in bleach solution can be found by a reaction with iodide ions. The overall equation for this reaction is shown below, so we've got that there. A sample of bleach solution was found to contain ClO- ions with a concentration of 0.0109, so I'm going to label that with a C. Potassium iodide is added to a 20 centimeters cubed portion of this bleach solution. So again, I'm going to label that with a V. They want us to calculate the mass in milligrams of potassium iodide needed to react with all of the ClO- ions in this sample of bleach, giving our answer to the appropriate number of significant figures and also stating one observation we have during this reaction. So, I've been given the concentration and volume of ClO minus ions. So I can use that to work out the number of moles. Now I'm going to just transfer this first bit of my equation underneath. So I've got ClO minus and 2 iodine ions. What I can then do is record the values that I've already been given. So I've got a concentration of 0.0109. I've got a volume of 20 centimetres cubed. Now in order to work out the number of moles, I'm going to need to convert that to decimeters cubed, making sure to record my working out. So I've got 0.02, and then I can use that to work out the number of moles of ClO ions, which I get as 2.18 times 10 to the minus 4. Now, if I have the number of moles of that, I can work out the number of moles of iodide ions as well by taking that number and multiplying it by 2, because I can see there is a 1:2 ratio of chlorate ions to iodide ions, which gives me 4.36 times 10 to the minus 4. Now what I actually want to work out here then is the mass of iodide ions. So if I want to work out the mass, I'm going to need the molecular mass to do so. Now the trick here to remember is that we've actually got potassium iodide, so we're not going to use just the molecular mass of iodine on its own, we're going to also need to add the potassium to that. So the molecular mass here must be of Ki, and it must be 166. This then means that our mass calculation is going to be the molecular mass, which we just said was 166, multiplied by the number of moles, which is 4.36 times 10 to the minus 4. That then gives us 0.0723 grams. Remembering then that the question wants the answer in milligrams, so we're going to times that by 1,000. 2.376. Now we need to make sure that we have this in the right number of significant figures. So looking back through our answer, we can see that the smallest number of significant figures that we have been given is 3, so we're going to need to give that in 3 significant figures, which should be 72.4 milligrams. Observations then, I'm going to need to go back to my equation and think about what I would observe here. Well, I've got the production of iodine, chloride ions and water. So our observations are going to come from the production of the iodine, and what we're actually going to see is the production of a black solid. Check the mark scheme as there are other available answers there as well. For the next bit then, we're told that potassium chlorate is used in fireworks. Now when potassium chlorate decomposes, it produces potassium chloride and oxygen. We've got to give an equation for that and use the data to calculate the enthalpy change of this reaction. So I'm going to start off with the equation. We're told that potassium chlorate is KClO4 and that it decomposes into potassium chloride, which I know to be KCl, and oxygen, which I know exists as O2. So I'm going to need to balance that to make sure it's the same on either side. I've then been given the enthalpy of formation data for KClO4 and KCl. That means that when I come to draw a Hess cycle for this, the elements are going to have to go on the bottom of my Hess cycle. So I've got K, Cl2 and O2. My arrows are then going to point from these elements at the bottom to the substances within my equation. So I've got an enthalpy change of minus 434 to produce KClO4, and then I've got minus 436 to produce KCl. And I'm going to change colours here so I can follow what I'm doing in my calculation. I want to get from KClO4 to this side, KCl and 2O2. So I'm going to have to reverse the direction of this arrow and have a positive enthalpy change. And I'm going to keep this one the same. So my final calculation is going to be plus 434 plus minus 436, which will give me an overall enthalpy change of minus 2 kilojoules per mole.